Hi boys and girls, I just wanted to take a few minutes to quickly check in about your math task that you're working on today. I know that it might be a little intimidating when you first look at it because it's something that you haven't really seen before and something that I wasn't able to go over with you in class. So in the previous lessons you did a little bit about how different quadrilaterals relate to each other and how a quadrilateral, just because it looks like one shape that you're familiar with. When you look at a square, you're going to say, oh, that's a square, because you know what a square looks like, that it also might have a different name. So I typed up kind of a long paragraph for you, and I thought that just kind of saying it out loud and drawing it out for you will be the same. So this is exactly what I typed out in your little math section, but I'm just going to say it for you and draw those pictures so that it's helpful for some of those who need to see it visually. So like I said, that the math task is about understanding which quadrilaterals are related, that there's like families that they're all in, and that those quadrilaterals can have more than one name. So for example, I said that a square, if we look at a square, if I just asked you to draw a square, I know that all of you would probably draw me something like this. You would draw me something that had 4 right angles and where all of the sides are equal in length. We know that this is a square. That's what you would probably all draw. But from what we are learning in math about our quadrilaterals, a square is also in the same family as a lot of other quadrilaterals. And I'm going to give you an example of one of those because I want you to figure the other ones out on your own. So think about the attributes of a square. And we know, like I said, that squares have 2 pairs of parallel lines. We know that they will never touch going this direction, and they will never touch going this direction. So I'm thinking and I'm wondering, and I know you're thinking and wondering too, and the first thing that comes to mind is a parallelogram. Well, why? Because we know from its name that a parallelogram has 2 pairs that are opposite from each other of parallel lines. So another name for a square is a parallelogram. Now there are others too, and you'll see that on your math task, but I want you to figure them out. So what are those other ones? Okay, the other example that I gave for you is a rhombus. So if I asked you to draw me a rhombus, you would draw, let's see if I can draw it the best that I can, something that looked like this. Kind of looks like a parallelogram, but what's different about it is that all the sides are congruent. I could probably have done a better job, but that's the best I can do with my markers right now. So all the sides are equal in length, okay? They're all congruent. These are the same length. So I'm wondering, is there another quadrilateral that I can think of where all of the sides are the same length? And I'm thinking, and you're thinking, and we're thinking together. And that would be a square, because we know that a square has all 4 sides that are equal in length. So another name for a rhombus would be a square, okay? So I don't want to give away all of the answers because I want you to do some thinking on your own. The only other thing that was actually a little bit confusing to me is that when we think of a trapezoid, we think of one set of parallel sides, right? One pair right here, okay? But in our book, the definition of a trapezoid is at least 1 pair of parallel sides, okay? So when it says at least, that means that actually all the quadrilaterals that we've been talking about have at least 1 pair of parallel sides. So the trapezoid will fit into all of those categories. It's kind of, even though on the images that I put, it always says the trapezoid is by itself, but from the definition from our book, it says that they are, that it has to have at least, okay? So we have to make sure that we're using the definition from our book, so it will fit into all the categories. Okay, so I put some pictures for you below, so remember that the trapezoid is actually going to go in the parallelogram, that whole family. I also put a link to a YouTube video where he's explaining this again and showing you a bigger diagram, and I actually like that diagram a lot better than the one in your book. I think the one in your book might be a little tricky. If some of you like that one, then totally go for it if you can figure that out on your own. But otherwise, you can draw the diagram that our friend on YouTube drew, if that makes more sense to you. I'm going to post the answers to your Parents Member Hub, so you can look at that from their end once you try. So I don't want this to be overwhelming for you. I want you to just try and take on this challenge. It's okay if you don't fully understand it. We're going to go over it again another day. We'll come back and review it. So just try your best for me and ask me whatever questions you have. All right? Have fun. Keep up the good work.